So guys, today we're going to see about new topic. So that's convolutional neural network. So it's one of the deep learning techniques. Okay. So I'll tell you, guys, in our Google Lens, if you're taking any picture, what it does? Tell me. If you're taking any picture, it may are animals or objects or anything. What it happens is so
Yeah, it shows other options related to that, similar to that.
yes. So it shows the output, right? So if it is tiger image, it predict as a tiger, right? Is so if it is chair or laptop or any other accessories or refrigerator or fan or anything, so it automatically detects the object, right? Say yes or
Yes,
no. So we have
Yes.
in Amazon also we have, right? So in that lens, if you are using any objects, it automatically displays, right?
yes,
Yes. Oh,
Yes.
okay. The same concept, guys. So the first one is the input layer. So it gets the input from the users. So I will give one sample image. So just see carefully. So I will give us a one sample image. The height is 5 and the width is 5. Okay. And the channel is 3. So 3 means, look at her. So 3 means that this is the channel. So if it is in RGB color, so we give as a 3. If it is a black and white, so we will call it as 1. Have you got my point? If it is black and white, we will call it as 1. If it is RGB color, so it is the color image. It is the color image. We will call it as RGB, or else we will give as a 3. Okay. If it is black and white, or else grayscale image, so we call it as black and white, so we will represent as a 1. So have you got my point? Sample, weights, height, width, channels, have you got my point? Yes. Okay.
Yes.
So in your image it's separated as a grid pattern. You already know the grid pattern, right? So in your mobile phone has also have grid pattern, right? So the boxes, right? Grid patterns.
Yes. Yes.
So it's
yes,
separated as a grid. So we are already studying the matrix in our school days. So here they are applying the matrices 0, 1, 2, 3. I just giving randomly. So don't confirm that 7, 8, 9. Okay. So this is the matrix. So it's a 3 cross 3 matrix, right?
yeah,
Yes,
right.
Yes.
each box has a 3 cross 3 matrix. Each box has a 3 cross 3 matrix. So we call it as kernel. The box name is kernel or filter. We call it as kernel or filter. So it's
Center. Yeah,
kernel size is 3 cross 3 matrix, right? Each kernel has a matrix. Say yes or no. Okay.
yes,
So the remaining things are padding. So in your passport size photo, your photo is the object, right? Your faces. So remaining background, blue color backgrounds or something white backgrounds are padding. Okay. So here the padding is uh, exclude the tiger. Okay. Here the padding is excluded the tiger. Have you got my point? Which one is padding? Have you got my point?
yes,
Background of the tiger. So we need tiger image only, so no need the background image. Okay. So the paddings are in zeros, guys. The paddings are in zeros. Okay. So not in numbers. The paddings are zeros. Depends on weightage. The number will change and depends on weighting. The number range is, I tell you, the number range starts from 0 to 255. The number range starts with 0 to 255. Okay, this is the range of RGB color. Paddings are 3 cross 3 matrix, all are in one zeros. So if it is weightages, I will give the weightages for 0, 25, 30, 0, 98, 99, 0, 81, 95. Have you got it? How I give the matrices? Have you got my point? I just give one. Have you got my point? Yes. Okay. So convolutional layer means it extract the features. It extract the features. So here all the filters in order. So guys, see here all the filters. I already told, right? We call it as kernel, or otherwise we call it as filters. So all the filters will be here. Have you got my point? You just assume that here are the 32 filters in order. Have you got my point, guys?
Okay.
Hmm.
So all the matrices are in 3 into
Ah,
2,
arranged in, yes, like
right? And the range is between 0 to 225, depends on the color.
yeah. Have you got my
Okay.
point? And this is the order,
Yeah.
one by one. Have you seen the card? We have 52 cards, right? So one is a heart symbol. So another one is diamond. So another one is what? Something the leaf, right? So leaf symbol. And another one is heart, leaf. And another one is something like leaf, right? So in our cards, how many cards will be there? 52 cards, right? So 52 cards. So these are the categories: 32 13 hearts, 13 diamond, 13 leaf, or something is 13. Okay, so guys, listen. So if you order one by one, if you order one by one as a filters, we call it as stride one. We call it as what? So we call it as stride one. Okay, if it is 2 by 2 slides, so we call it a stride 2. Have you got my point? If it is 1 by 1 slide, so we call it as stride 1. If it is 2 slides, we call it as 2 stride. Have you got my point? Say yes or no. Yes, have you got my point? Did you understand?
Can you repeat this one again?
So stride, look at this, look at here. See, this is the stride. So if it is stride one, means it order one by one. One filter, two filter, three filter, four filter, one by one. So
Okay.
if it is stride two, it the two filters on two filters on one. Have you got my point? This is the two filter, and this is the another two filter, and this is the another two filter.
Okay. Okay. So
That
at a
means
time,
two
two
stride.
filters are coming.
Two slides are attached, right?
Two slides are, yeah.
Ah, yes,
Okay.
yes, yes. So this is 3 cross 3 matrix. So it's 3 cross 3 matrix, and pooling layer means it reduces the size. It reduces the size. So it convert as a 2 cross 2 matrix. It means it has only 2 rows, 2 columns. So I just give the example. So it's in a 2 cross 2 matrix. Have you got my point? So convolutional layer means extract the features. Pooling layer means reduce the features. Have you got my point? So it's in 3 cross 3 dimension, it has 2 cross 2 dimension. Have you got my point, guys?
Yes.
Hmm. So the two-dimension matrix automatically converts as a one dimension. That is called flatten layer. So flatten layer means it convert 2D into one dimension. So see the list here. So this is a one dimension matrix, guys. Have you got my point? Flatten layer. Yes or no?
Yes.
So
Yes.
all the layers are connected as these neurons. So we call it as dense layer, or else we call it as fully connected layer. So all the points will pointed on neuron. So this is called dense layer. So we just predict. So if it is tiger, so it may predict 99 percentage. This is 80 percentage, and this is 70 percentage. Which one is highest? Which one is highest? Tiger or leopard or cat?
Yeah.
Tiger. So the predicted output is what? Tiger. Is right. Ah. So see,
Yes.
I want to tell one thing. So see, so this is the padding. So this is the padding. If it is no padding means only validity. Only takes the tiger image. Only takes the
Evidence.
tiger image. Guys, so padding. I already told, right? So background is called what? padding. So
padding.
Padding.
if you take the image as padding also, you can give us the same. You can give us the same padding p equal to 1. If you no taken no padding, you just valid data means only you are taking tiger image only valid means you only taking the tiger image. Same means you are taking all the images background also including. Have you got my point? Yes. So guys, these are the layers. These are the layers we call it as hidden layer. You people don't know the concept, right? So we can't see, but this is the concept. This is the hidden layer. Have you got my point? Yesterday I told, right? So input layer, hidden layer, another one is what? Output layer, right? So hidden layers, these are the process will happen. So convolutional layer, pooling layer, flatten layer, dense layer. Have you got my point? So input layer gets the input from the user, and convolutional layer extract the features, filters one by one, and pooling layers one, it reduces the sizes, and what it does, flatten layer, it convert as a 2D to 1 dimensions, and dense layer means fully connected, all the layers will be connected as a dense, and it predict the output. Have you got my point? Do you have any doubts in this slide? Do you have any doubt? So we will move on our theory concept. Have you understood this concept?
Yes.
Okay, that's good.
Uh,
Okay.
I think bottom is not here.
Okay, Alta, you just take a snap.
Yeah.
Okay, so we will move on the theory concept just to see. So guys, I already told, right? So convolutional layer is a type of deep learning model. So this is mainly using for image data, but also effectively using for what? It can also using video, it can also use audio, and it even we are using for text classification. So audio means we will separate the audio and karaoke, right? So in audio, we will separate the song and karaoke, right? Yes or no?
Yeah.
Yeah.
Mm.
And
Yeah.
even we are using for text classification also. You can write any number on your A4 sheet. Just take a snap. It automatically predict the number, right? So guys, in your Google Lens, whatever you people are writing or grocery list or your mark sheet, it automatically detects the number, right? Numbers and alphabets, right?
Yeah.
So it's used for text classification. Why we are using means, so it's automatically adaptive learning spatial hierarchies. So spatial hierarchy means it learns edges, patterns, each and everything. If you people are kids, I'm just giving the Apple label stickers, so it automatically detects the patterns and sizes, edges, right? Yes or no?
Yes.
Okay, so it's get the input from the users, and using convolutional layer it extract the features. Okay, where we are using means, we are using for image classification. In X-ray also we are using, right? X-ray we are seeing the skeleton image, right? So here also we are using CNN, and object detections also we are using. So object detection means it detects vehicles and helmet, right? So in surveillance camera, so it also seeing, and in face recognition also we all are have face lock, right? So this is used for face recognitions, and I already told, right, handwritten digits recognitions. If you are writing something and take a snap on Google Lens, it automatically detects the digits. And satellite also, we are seeing the satellite image, right? We are seeing the earth and moon sun in using satellite image, right? Is sir.
Yes.
Yes, we are using, and we are using self-driving car also. If self-driving car means without driver, so autonomous car vehicles. So it automatically see the road lands and see the signals, and if any pedestrians are walking on the road, so it automatically detects and stop the car. Have you got my point? So these are all are the using applications using CNN. Okay, CNN concepts. Okay, architecture. I'll tell you. Just you can download any image. You can download any image on your Google's. This is my image name. Okay, CNN.jpg. So I am directly read the image. But your Python notebook program and your image also in same folder, should be in same folder, then only it automatically reads the image. Okay, you can give any sizes, you can give any title. Okay, I just given for my class teaching purpose only. Okay, have you understood the tiger image? This is the sample image for duck. Have you got my point, guys? Do you have any doubts in this image?
No.
That's good. So you people are learn 50% of concepts here in while listening the classes. Then remaining 20% you people definitely do the code, and remaining 30% daily you have to revise the concept. Then only the concepts will be you can understand. Okay, this is the architecture component, just listen carefully. This is the input layer. So I already told, right, height, width and channel. If it is 28, this is the height and width. If the channel is 1, means what it happened, black and white, right? So if it is 1, black and white or grayscale image. So if it is RGB color, it returns as a 3. So I already told, right? So grayscale means black and white. So then only the channel is 1. It is RGB color. So color image. Then only the image it will returns as a 3. And MNIST. So MNIST also black and white image, and Cipher also 10 color image. We will see the use cases. So don't worry, Surya. Okay, and come to convolutional. I already told, right, it applies the filters and kernels to extract the features, right, edges and textures, all things it extracting all the things. Okay, each filter produces a feature map. It has a mapping the element. So come to here, I already told, right, number of filters we call it as tried, right? I already given as a 32 filters in the image. See, 32 filters in the image and convolutional neural network. Okay, the size is 3 cross 3. Stride, I already told, right, number of pixels. Filter moves. So if it is one by one slide, so it automatically shows as the filters, right? So come to padding. So these are the extra rows and columns. So usually it's in zeros. I already told, right? So in tiger background, so all are in zeros, right? So all the background images are zeros, right? So this is called padding. Have you got my point, guys?
Yes.
uh, Only background image only, not tiger image. Okay, then so if it is you want valid image, so this is called no padding. If you want same means it automatically takes all the input, so this is called zero padding. Okay, zero padding means we will applying zeros, right? Then only we call it as zero padding. Have you got my point? Okay, so this is the formula to find the padding. Now no needed, but you have to know this formula. Okay, output size, and another one is activation function. This is very important. So I already told, right? So in last deep learning concepts, so relu is one of the activation functions to filtering the non-linearity. So it only returns the positive value from 0 to infinity, right? So the range is 0 to infinity. Okay, the pooling layers reduce the spatial dimension. Spatial dimension means a height and width. It automatically reduces the spatial dimensions, and it helps for control the overfitting. Okay, and easily compute it. Okay, so this is the formula of pooling layer. Just read it out. Okay, and the next one is flatten layer. I already told, right? So it convert as a 2D into one dimension, and before what it happened before feeding into fully connected network, what flatten layer does, it automatically converts as a 2D to one dimension before giving before we will adding to the dense layer, right? So feeding into the fully connected layer, or we call it as dense layer. Okay, and I already told, right? So fully connected layer means we call it as dense layer. So it is the help of final prediction, and the final output is, so here we can use any output layer, like any activation, softmax or sigmoid or linear. If you are using binary classification, if you are finding male or female, or 1 or 0, you can use sigmoid. If you are using multiple class, if it means we are 3 persons are here, right? So we are using face recognition. So which one you people are using, sigmoid or softmax? Which activation you people are using now? For 3 persons,
Softmax.
softmax. If only you two people only. So what activation you will be done? Sigmoid.
Like for male and female to identify
Uh,
only two categories at that
uh,
point of time,
yes,
sigmoid we
yeah,
will use.
yes. If you are using two possible outcomes, you can use sigmoid. Or else, if you are using multi-class classification, you can use a softmax. Have you got my point? Yes.
Yes.
I'll give one example. So, MNIST handwritten digits. So, we are now moved deep learning concept. So, then only we are importing the TensorFlow. Shortly, you give us alias name is TF. So, in TensorFlow Keras, we have the data set, guys. No need to download anywhere. Just, we have the data set of MNIST. So the MNIST full form is Modified National Institute of Standard and Technology Database. You just call it as MNIST is enough. Okay. The model is sequential. The layer is convolutional 2D, max pooling, flat and dense input. There is no changes. You people are exactly take as the name, capitalize and small case. You can write like that. And the utils we are using two categorical. The images are automatically convert as a categorical. I'll tell you. Okay. In dataset we will just give us the MNIST load data. Okay. So you if you are giving xtrain and ytrain, so it automatically separated as a xtrain and ytest. Have you got my point? It automatically convert as a x test and y test, x train and y train. Okay. You can see any image. So guys, in this, so now tell me, so what is the image now? What's the number is present inside the image?
Number தெரியாது but black and white category.
So the number is 0. The number is what?
Zero.
0. Okay. Not 1. Okay. So see, here I am. If you want to see the image, you can use the matplotlib. You just initialize 1. You can see the image. X train 1, y train 1. It's just x train 1, y train 1 means x train means the image, y train means the label 0. Okay. The color map is gray color. So gray means black and white. It automatically shows us the black and white. You already know the format string. Okay. If you are given if you are given 0th index, what it returns? What's the number here?
Is it 5?
Three.
Yeah, I tell you on 1 minute. Okay, see guys, our data set will be separated as a different. So you just imagine. So this is our data set. I'll tell you. This is the X train, and this is the Y train. So you just assume our data is one be stored like this. Okay. So 0th index is 5. 0th index is 5 image. The label is Y is what? 5, and 1 is what? What is the 1 index? So it's in 0 image, and the label is what? 0. Okay. So now I'll give another one. So if I give one 2, what's the second index here? See and tell me.
4.
The second index is 4, guys. So this is the image of 4. What about next? Wait a minute. I'll just give. So these are the index like that, guys. What's my third index? What's the
Is it
image?
1?
Seven.
One. Wait,
Okay.
wait. I'll show you. Just the image will be like that. Have you assumed that this is our data set like this? So how the image will be stored as? How the image will be stored as? Here sample is there. Here sample and width. Sorry, and height and width, and another one is channel. Okay. So and this is the rows and columns, right? This is the rows and columns. So guys, I tell you, this is the one image, Gautam. Okay. So guys, these are the
Okay.
data set already they are trained. You just give us a one. So this is enough. Okay. We can see the data. Okay. So here, see here. So X train. I want to reshape. Why I am giving -1? Tell me now. Why I am giving -1? So this is the last index, right? This is the last index. Guys, if you want to see the count of students, you can ask the last students, right? Or ration shop or any other meeting. Yes or no?
Yes.
Hmm. You can easily find the last number, right? So how that much of data will be there. So all are in what height and width is 28, and the channel is what 1, black and white. So should be in 255, guys, in float value. Then only I am giving divided by 255. Okay, the range should be in 255. Okay, that's the color range. Have you got my point?
Yes.
Hmm. And just running the line coding. So same of X test. Now tell me how many datas will be samples are here X train? How many samples are here? 60,000. How many samples are X test? X test.
10,000.
Total?
70,000.
Hmm. So total we have 70,000 image. But I here just given as a 4 images only, and total we have one 70,000 image. Like it stored like this kind of X and Y. Have you got my point? X we are storing images and Y we are storing the numbers. Have you got my point?
Hmm.
Hmm.
So these are all predefined already.
Yes, yes, yes. Already trained, not
Okay.
defined. We have already
Oh,
trained.
okay, okay.
We
By the
just
institute that you have mentioned.
yeah, we just using trained model for our use
Okay,
cases.
okay, got it.
Okay, I'll tell you. Guys, these concepts really very fantastic concepts. Okay, so don't worry. So we will convert as a one hot encoding. Just I'm using the two categorical function. You just give the y train and y test, and just see here what is the y train 0, and what is y test 0. Guys, what's the now tell me what is the number of y test 0? Sorry, y train 0. Now tell me what's the number here?
5.
5. So now where 1 presents? So it is one hot only in zeros and ones. Where it presents? So it is
Index
the
number 5.
not like that. This is the zeroth image. This is the first image. This is, guys, you can write A4 sheet as a 0. So this is the 0 image. This is the 1 image.
So,
This is the 2 image, and 3 image, 4 image. What's the image now?
Fifth image.
5,
15.
5, 5. So here is 9, guys. So it starts from 0. Starts from 0. First is 0. So what's the image now here?
5.
5. Wait, I will give another index. Now tell me, so what is the image of another index here?
0.
So where 1 presents?
At 0.
So
So,
automatically it predicts as a 1. So guys, if we are giving attendance like that, first one is Alka, second one is Gautam, and third one is Vasant. If one presents Vasant name, if one presents third one, so who's the answer here?
So so whatever the image that is present in the Y
If it is present, it
try,
returns 1, guys. If it is
it
not
is the
present,
number. Hmm.
so that is called one hot encoding. So it's already in ones and zeros, right? Uh,
Oh, okay, okay.
hmm.
Whenever the present is there, one will present.
So you just listen. I will give us the second index. So you can guess. So what is the number here?
4.
that
Yes,
makes
yes,
sense.
yes, yes. Have you got the point? So the next one is what? Next one is what? One.
One.
So I will give it. Uh, Have you got my point? Have you got my point? Have you understood?
Yes.
Uh, this is easy, guys, so don't worry. Okay, so we just see the data. So how it categorical? Okay, so we want to draw the diagram. We want to draw the diagram. I already told, right? So it's in tiger image. So just to take a snap, I will move the another image. Just take a snap. So you can draw the image in coding. You can draw the image in coding. I tell you, just see the coding. So first one is input, right? So first one is input. What's the shape, height and width? 28. And what's the filter now? 1.
Black and white.
Yes, just imagine. It's not a tiger image, it's a number image. Just imagine. Okay. And the next one is convolutional 2D, and the next one is convolutional 2D. So the layer size is what? 32 filters, right? The layer size is I already written here, right? So what's the convolutional layer size now? We will give as a 32 filters. We will give as a 32
32 filter
filters.
image.
So what's the size of the image? 3 cross 3 matrix. 3 cross 3 matrix. Here I'm using the activation ReLU. Activation function is ReLU. Have you got my point? Convolutional layer. Have you got my point? Just you can imagine the image and write the code. Have you got my point?
Okay.
Yes or no? Okay. And the next
Yes,
one is
yes.
pooling layer. So what's the size of pooling layer? 2 cross 2 matrix. Is right. So it automatically converts as a 2 cross 2 matrix. Have you got my point? And the next one is,
Yeah.
guys, if you want needed, you can give again convolution and max pooling. Here I'm no needed, then only I'm giving as a flatten layer. Now tell me what it does. Flatten layer will convert as a 2D to one dimension, right? Yes.
Yeah, yeah.
The next one is dense layer. So dense layer means it connected as a 128 neurons. It connected as a 128 neurons. Here I draw only 5 neurons only. Here I draw only 5 neurons only. So it may become, how many neurons will be there? 28. So dense layers will be connected as a 28. So what is the output now? What is the output now? 10 outputs. What are the possible outcomes? So it may be 0 image, or it may be 1 image, it may be 2 image. Then only I'm using a softmax activation function. Have you got my point?
How
Yes.
to take this number 128? Like yesterday we took dense 16 and 8. So how we decide to take this number?
Which one, Alka? 128.
Dense 128 we are taking, and yesterday
Alka,
we took
you can give any
16 and
dense.
8,
You
right?
can give any number of dense vector.
Any number.
Hmm. But in
Okay.
commonly in some companies are using some initial numbers, so you can use like that. Okay. And what's the output here? Only 10 possible outcomes. So yesterday we seen breast cancer, right? So benign or
Yeah.
malignant. So there we are using sigmoid. And what the possible outcomes there? One.
Only
So
two.
uh, so
What?
only two, but what's the output? So you just see,
One.
take one record, what it predicts. We are using sigmoid.
Yeah, it was
So what's the output? Yesterday we are using one output, right?
Only one output.
One.
Either malignant or
yeah,
benign.
one.
Yes, here 10 possible outcomes. One, it may be zero, either one or two or three or four or any numbers. Have you got it? Yes.
Yeah.
uh, so see, and the next one is extra in shape. So extra in shape, I tell you. So we just see the shape, no needed. Okay. And here the optimizer, we are using the atom for reading purpose, and we will check the loss using categorical cross entropy and matrices. Yesterday I told, right? So we are using 5 epochs. So train is a 5. So now tell me what is the accuracy? 99, and the loss is 1. Okay, and we will give the batch sizes of 32. So if your batch size is 32, how many badges will be there? 1688 badges, one by one. And you can take the validation testing for 10 percentage. Guys, tell me, 10 percentage means 10 divided by 100. So if 10 divided by 100 means 0.1. So we will,
Zero.
guys, if you are cooking rice, right? We will testing a little amount of rices, right? If the rice
Yes.
cooked or not. Yes or no?
Yes, yes.
So we will just
Yeah.
take a 10 percentage of data and checking the validation accuracy. Validation accuracy also 98, right? Yes, we will give the evaluation model. So now what's the accuracy now? 98. So one of my two students told, right, to change the hyperparameter. Here I given the epochs 5, but my student told the epochs is 10 and the batch size is 50. Now see my accuracy. So what's the accuracy now?
99%.
So depends on training, depends on changing the hyperparameter tuning. So these I already told yesterday, right? So in yesterday after regularization concept I told, right, epochs, batch size and validation and learning rate, like that, these are the hyperparameter tuning. If you want to prepare well, or you want the best accuracy, you can train the hyperparameter tuning. Have you got my point? So in so how many marks you people are completed? Basics, libraries, and machine learnings. Yes, you people are completed 3 marks, right? So have you seen Alka? Have what's the difference between first mark and third mark, Alka, in your self introduction? So what's the difference?
Yeah, there is huge difference. Yeah, difference like first I was not knowing even terms. I was
Uh,
not confident
yes,
also,
yes,
but
yes.
the
Uh,
third one it was good.
if you are
Hmm.
in fifth and tenth mark, you will be in excellent. So this like that we are using our training model. Have you got my point? Yeah. I'll just scroll down the page. You first complete the
Yeah.
coding, guys. Then only you people take the notes on your notebook. You can write any note paper. Okay. Definitely we will not make sure in our document. So you can take your notes. Buy one note and write it. Okay. Just do the coding on your VS Code. Okay. Do you have any doubts in this session, guys? Yes.
Nothing as of now.
Yeah, that's good. What about Alka?
Yeah,
Okay,
not
okay.
now.
Hmm.